Okay, so good morning, everyone. So, first of all, uh, wish you a very happy and prosperous new year. So, today we'll be discussing about measurement of morbidity and mortality, and this is one of the most important pillar when we study epidemiology. So, before going to that, let me start with a famous phrase given in the book called Park. It is written that I keep six honest serving men. They taught me all I know, and their names are what, why, when, how, where, and who. So, when you have this knack of asking questions, you know, what, what is this? Why it has happened? When it has happened? How it has happened? Where it has happened? Who are affected? So you come to know this should be your epidemiological approach. So this is a very famous saying given in the book Park. So whenever we discuss about epidemiology, you always need to have this approach. You need to ask questions and you need to inquire about things. And once you have information, so this is your first epidemiological approach. The second, what you do once you have the information on this, then what you are going to do, students, you are going to compare. Okay, so comparison has to be done. So whatever information you have got, how if I compare with the other study, other gold standard or other information you have, so where do you stand? So this is the epidemiological approach. So just a second, I'll take this is a picture, a half glass. So it is filled half. So if you ask a person, a pessimistic person, the pessimistic person will say the glass is half empty. Yeah. The optimistic person will say the glass is half full. The epidemiologist will say, no, okay, as compared to what? Epidemiologists are interested in making comparison. Unless until you don't do comparison, you're not going to reach to any conclusion. Okay. So before going to measurement of morbidity and mortality, let me define, what you say, epidemiology. So John M. Last gave a very beautiful definition. What is that epidemiology? Epidemiology is the study of distribution and determinants of health-related states or event in a specified population and the application of this study to the control of health problems. What is this? You are doing a study of what? Study of distribution. Distribution of what? Distribution of health related states or event. So the first component is study of the distribution of health related states or event. Second component you are trying to add is when you have done the study of distribution, you also want to do the study of determinants. What are the determinants of that health related states or event? So once you have done the study of distribution, once you have the information of distribution, once you have the information of determinants of health related states or event, in that population, what you do, the information which you have, you apply this study, the information, the knowledge which you have gained, you apply this study to the control of health problems. This is the way you do epidemiological study. So this is the definition of epidemiology. Okay. Now, students, let's not waste time. This is the most important slide, and if you understand the this slide in the spirit, the entire epidemiology becomes easy. There are three components of epidemiology. First is disease frequency, which I'll be talking today. Second is distribution of disease. Third is determinants of disease. Student, when I say disease frequency, these three components, these are the three important pillars. If you understand this, the entire epidemiology becomes easy. So let's take an example, practical example. Whenever you study a communicable disease or a non-communicable disease from a book, now any book, let's take Park. So what you study, the first it starts with an introduction, and then they write the problem statement. Global burden, national burden, means regional variation, state-wise distribution. So what is those things? Those things are disease frequency in the form of mortality, in the form morbidity. How many people are dying? So that indicates the severity of the disease, that indicates the magnitude of the disease. So how many people are dying? How many people are suffering from the disease? So what is the morbidity pattern? What is the mortality pattern? So that is disease frequency. So that is important. First you have to know what is the morbidity pattern, what is the mortality pattern. Once you know the magnitude of the disease, second, you want to study the distribution pattern of the disease. You are describing the disease with respect to time, place, and person. So that is distribution pattern of the disease. So you have understood the magnitude of the disease. You have studied the distribution pattern of the disease with respect to time, place, and person. So once you have studied that, so you are possibly reaching to a etiological hypothesis. So that distribution pattern of the disease in descriptive epidemiology helps you to generate a hypothesis. Once you have generated the hypothesis, that can be true, that may not be true also. So that need to be tested. So that testing of hypothesis is done by determinants of disease. You are attributing the risk factor or to a disease. So let's test that, is that risk factor a causative the agent of that disease or not. So that is done by determinants of disease. Students, these three important points now explain the entire epidemiology. First, measure the disease in terms of morbidity and mortality, which I'm going to talk now. Second, once you've measured it, you are trying to describe the disease with respect to time, place, and person. And once you have described the disease, you have reached to a possible etiological hypothesis, then you try to test the disease, means test the etiological hypothesis, that is called determinants of disease. Okay. Now, now let's go to measurement of morbidity and mortality, because that is important. Yeah. So first is measurement of mortality, students. It is the starting point for many epidemiological studies. Whenever you talk about any disease, the first thing which comes to our mind, how many deaths it is causing, what is the mortality, what is the fatality of that disease. So it is a resource for the epidemiologists. Okay, so measurement of mortality becomes very important. So this is just an international death certificate. Before going to that, I'll just explain this. This has got section 1, this has got section 2. Section 1, you say, if you see, it is it has got A, B, C, D. Now let's see what is this. A is what? The direct cause of death. The person has died due to which cause? So in the place where A it is written, you have to write the direct cause of the death. Now the person died due to A, due to or as a consequence of B. So B is the underlying cause. B led to A and A finally led to death. So the person died due to A. Okay, person died due to A as a consequence of B. Now person died due to A as a consequence of B, which is as a consequence of main underlying cause, which is written at the C. So the main antecedent or underlying cause becomes C. At times, students, there will be a possibility that you can reach to column D, row D also. Means the person died due to A as a consequence of B, which is as a consequence of C, which is as a consequence of D. And then you have section 2, which is the other significant conditions contributing to the death, but not related to the disease or condition causing it. So it is an indirect thing. So students, if any death certificate is filled till A, B, C only, normally it is filled till A, B, C. So the main antecedent or underlying cause become C. Okay. But in case the death certificate is filled till D, so the main antecedent or underlying cause will be 1D. So you have to be very smart. If you get a question on this, if the example says that the death certificate has got it is filled till D, then you should go with the answer 1D. But normally it is filled till 1C, so the main antecedent or underlying cause become 1C. Okay. Now let's take this example. In this example, you can see, students, the person died due to renal failure. It is a direct cause. That renal failure developed as a consequence of diabetic nephropathy, and this diabetic nephropathy is due to diabetes mellitus. So one here and D is not, 1D is not filled here. So 1D is not filled. It means that the main antecedent or underlying cause here is diabetes mellitus, and the other significant condition was hypertension. So once you get this type of information, you can say the main antecedent underlying cause is diabetes mellitus. Now let's take the second example. In this example, you see the person died due to intraperitoneal hemorrhage, which is filled in A, and that intraperitoneal hemorrhage happened due to rupture of metastatic deposit in liver. Okay, there was a metastasis in the liver, so that deposit in the liver ruptured, so that led to intraperitoneal hemorrhage. So this rupture metastatic deposit in liver is due to metastatic deposit in liver, so that is filled in 1C. And from where this metastasis deposit in liver came, it came from primary adenocarcinoma of ascending colon. So in this death certificate, since it is filled till 1D, so here the main antecedent or underlying cause becomes primary adenocarcinoma of ascending colon, and the other significant cause is hypertension. I'm once again reiterating, if it is filled till 1C, then your main antecedent underlying cause will be 1C. If it is filled till 1D, you should go with 1D as a main antecedent or underlying cause. Okay, hence 1C or 1D, whichever is filled, is known as essence of death certificate. Okay. Now coming to the mortality measurements. How do we measure? Simple. We measure crude death rate, we measure specific death rate, we measure proportional mortality rate, we measure case fatality rate, survival rate, and standardization of death rate, students. So if you talk with the first 5 boxes, more or less most of the students know. So the moment we talk about standardization, that is also known by many students. The only problem is that understanding of that. Do we understand standardization spirit or not? So we'll try to, I'll try to explain you all these things so that the concept of all this sticks to you for long term. Now let's start crude death rate. What is crude death rate, students? So how, if I ask what is death rate, what does it signifies? It says that number of deaths. Death rate means number of deaths. So number of death in an area in a year out of total population. Here we have taken mid-year population. So out of total population, how many people are dying? For example, there is a mid-year population is 5,000. So in 5,000, 10 people are dying. In 5,000, 10 people are dying. So how many will die in 1,000? Because we have expressed this in 1,000. So 1,000 is a multiplier. Simple. Number of deaths in a year in a given area out of total population, and you have expressed this in 1,000. So in simple terms, if I have to say, the example which I took, 5,000 population, 10 people dying. So in 1,000, how many people will die? So 10 divided by 5,000 into 1,000. Okay. Okay, I can see Shubham has joined. Great. Hello Shubham, how are you? Great. So this is the way we understand the formulas in community medicine. So I am not a great advocate of, I don't tell my students to learn formula except biostatistics and to certain area, because you need to understand. The moment you get puzzled with the formulas, then you're sticking to the formula. There is no need to learn this formula. In the total mid-year population, how many people died? So tell me in 1,000. This is crude death rate. So let's take the latest data, SRS data. Crude death rate of India at present is 6.3 per 1,000 mid-year population. So by understanding this crude death rate, we also know what is the current death rate of India, crude death rate of India, 6.3. Okay, so this is crude death rate. Since crude death rate and birth rate is very much similar, so it's not, crude birth rate is not a measurement of mortality. First of all, this is just because I have mentioned here, because whenever you talk about death rate, crude death rate, CDR, it also includes crude birth rate. Similar, out of total population, how many births have taken, express that in thousand, that is crude birth rate. As today, as the latest SRS data says, it is 20.2 per thousand median population. Okay. Now, so once we have understood crude death rate, so that is a crude data. No, it is not specifying anything. The total number of deaths it is taking in the population and expressed in thousand. Now we'll talk about specific death rate. Let's be more specific. So when you talk about specific, so you want to specifically, say something. So number of deaths from a specific cause. Tell me about how many deaths is happening due to TB. So that is specific. No? Number of deaths from a specific cause out of total population into 1000. So that is your specific death rate. Because this helps you to know what is the mortality pattern based on that disease. So this is by and large the better form of crude death rate. So crude death rate is a general crude data. So you are coming with specific death rate. Okay. Next, proportional mortality rate, student. Proportion is basically percentage. So suppose there are 100 deaths. Total deaths is 100. Now tell me how many deaths has happened due to TB. So number of deaths due to particular cause, the example which I took, I am saying here is total 100 deaths. Out of death, 10 death has been due to TB. So what is the proportion of TB death out of total death? Obviously, in 100 out of total deaths, 10 death has been has been due to TB. So what is the percentage of TB? That is proportion. That is proportional mortality rates. So it is a number of deaths due to particular cause out of total deaths, and you have taken the percentage, so it becomes proportional mortality rate. It is the simplest measure of estimating the burden of disease. Okay, it is a useful health status indicator. But this proportional mortality rate does not indicate the risk of members of population contracting or dying from the disease. Risk member of population, it is not explaining. Okay. Sorry. Now the next is case fatality rate. So there is a difference between students. There is a difference between proportional mortality and case fatality. Proportional mortality is out of total deaths. How many death is due to TB? Just as an example I gave. But when you talk about case fatality rate, it is not the same thing. It is what out of, now let's take here the example. Total, just a hypothetical example, 100 TB cases we have, 100 TB cases. Out of that, 10 was the death due to TB. So out of morbid condition, out of total diseased people, how many people are dying? So that is case fatality. Just that is the indication of fatality due to that disease. So 100 people were suffering from disease. Out of that, 10 people died due to that disease. So that is case fatality ratio or rate, whatever case fatality rate. And you have to take into percentage. So it indicates the killing power of the disease. No, it indicates the killing power of the disease, because out of total disease, how many people died? So it is very much related to virulence of the organism. The more the virulence, more is the fatality. Okay, so it is very much related to virulence of the organism, and it is just complement of survival rate, just antagonist to survival rate. How? Case fatality rate is said that it is 1 minus survival rate. So I'll be explaining what is survival rate also, so that you can correlate with that. So four terminologies we have discussed: crude birth rate, students, total deaths in per population, means out of total population how many deaths are happening, you are expressing in 1000. So that is crude death rate. Then second is specific death rate, death in the total population out of specific disease, that is specific death rate. The third we discussed proportional mortality rate, out of total deaths how many deaths you can attribute to a particular disease, what is the percentage of that, that is proportional mortality rate. The next one is case fatality rate, out of total disease how many people died due to that disease, that is case fatality rate. So it is very much related to virulence of the organism. Okay. Now it has got a correlation, it is complement of survival rate. So it is very important to understand survival rate also, students. So survival, as the word say, survive. So if you have diagnosed, or if you have diagnosed 100 cases of TB, for example, and you're treating them, so out of those people getting the treatment after diagnosis, so how many people survived after 5 years, for example? So that is your survival rate. Simple survival. So you have diagnosed people, you have started the treatment. So why are you doing the diagnosis? Why are you doing the treatment? You are only doing all these things just to make the patient live longer. So after 5 years, how many people survived out of total patients diagnosed and treated? That is survival rate. Okay. So this is obviously, this is survival, and case fatality is just the death. So both are antagonists. So case fatality rate is equal to 1 minus survival rate also. So in survival rate, what does it indicates? It indicates the prognosis in certain disease conditions. It is very useful in cancer studies, and it is the yardsticks for assessment of standard of therapy, students. So this, all the boxes which I have made, these are questions. These are one liner framed. One liner framed when it is asked in as MCQs. So survival, which indicator is the yardsticks for assessment of standard of therapy? So that is survival rate. How do you judge the treatment standard of therapy? By survival rate, how many people are going to survive? So this is just an antagonist to case fatality rate. Now, the most important one is standardization of death rate. Believe me, students generally know standardization. I'm not saying that they don't know. Okay, this is, we'll just explain standardization of death rate, and then we'll be taking the means questions the students have. So standardization of death rate, when I talk about students, is why we do standardization. Standardization is done because suppose we take crude death rate of one population, and we are trying to compare the crude death rate of with another population. Let's say one city with another city, or one composition age, one country to another country. Is it the crude death rate? It is as important. Is this indicator which you can compare? Is this the crude death rate is an important thing? No. When you have to compare death rate with two population, crude death rate is not the right yardstick. It's not the right yardstick, because why you cannot use crude death rate? Because you have different age composition. Suppose one community or one city you're taking, their age composition is different, the other age composition different. So crude death rate is not the right thing to compare. Why? Because the age compositions are different. So you need to do what? Age standardization. So you have to do a standard, you have to standardize it. Why you have to do standardization? Because you have to remove the confounding effect of different age structures, because age acts as a confounder. So let's remove the this age which acts as a confounder. So how do you do that? So you need to standardize it. So standardization can be done direct, it can be done indirect. So whenever you do standardization, students, it generally starts by taking a standard population. The last line, please focus on the last line also. Generally, we take the standard population as national population, but it is not mandatory, students, that national population will be always taken as standard population. Okay. Till this, you can say that okay, standardization is done because age compositions are different of two populations. So to remove the confounding effect of age, we need to do standardization. It is direct or indirect. It can be direct also, it can be indirect also, and we take a standard population, and national population need not be the always be taken as standard population. But how it is done, that has to be understood. So it is of two types: direct standardization, indirect standardization. Let's take first, how do you do direct standardization? So in direct standardization, students, what we do, we take age specific death rate of the population. Okay, the age specific death rate of the population is applied on the standard population. The first point, Please remember, age-specific death rate of a population is applied on the standard population. When you have applied age-specific death rate on a standard population, you calculate the expected death. That is total expected death. And once you have the expected death, then you what you do that you divide the expected death by total standardized population to yield a standardized death rate. Okay, you can say till now, okay, all these things are theoretical. Let's take an example to understand. Now, students, see this. You have two cities, London and Camden. Okay, London crude death rate is 7.5. Camden crude death rate is 6.5. Crude death rate. So, if you compare the crude death rate, 7.5 is London, 6.5 is Camden. You can say Camden is a better performing city as compared to London. But as we have discussed, crude death rate is not the ideal yardstick to compare because age compositions is different. We have also got age-specific death rate of London also and Camden also. It is given. If you can see, 0 to 4 year age group, you have 10 specific death rate. 5 to 14 you have 3.3, 15 44 3.3, 45 to 64 7.5, 65 25. So all these age specific death rates of London is given. Age specific death rate of Camden is also given. So this is given. Now what the first step of standardization, direct standardization is, we take a standard population. Now this is the standard population, Euro population B. We have taken here in London also, we have taken in Camden also. Okay. So standard population is of 1 lakh total. So we have divided into the age composition 10,000, 10,000, all it's given here. Now what I am telling you, let's start with London. The first step of direct standardization was what? Just apply this age specific death rate on the standard population. Okay. Now see, I'll explain what is this. So what is this 10? If I have to say in sentence, if I will make a sentence, there are 10 deaths of children is happening. 10 deaths of children is happening per 1,000 population in the age group of 0 to 4 years. This is the meaning of this 10. So if I say students, 10 children are dying per 1,000 population in 0 to 4 year age group. This is the actual data which is given, which we have got from London. So how many children will die in 10,000 population? Because what we have to do, we have to apply this age specific death rate on this Euro population, which is the standard population. So if 10 children are dying per 1,000 population in the age group of 0 to 4, so how many expected death will be in 10,000? So just they have calculated 100. In similar fashion, 3.3 people or children are dying in the age group of 5 to 14 per 1,000 population. How many children will die in 10,000 population? That is 33. Similarly, 3.3 people are dying per 1,000 population 15 to 44. How many people will die in 35,000 population? This is the expected death. Similarly, for 45 to 64, 65. So, in totality, in London, 936 people died, expected death. This was expected death per 1 lakh population. Okay. Now, if I ask you, in 1 lakh population, 936 is the expected death. Okay, so what will be in 1,000? So that is your direct standardized rate. So that comes around 9.4. Okay, so we have direct standardized rate for London 9.4. Similarly, you do for Camden also. Let's take Camden. Age specific death rate is 13.8 in the age group 0 to 4. So 13.8 children are dying per 1,000 population in 0 to 4 year age group. So if 13.8 children are dying in 0 to 4 year age group per 1,000 population, how many people will die in 10,000? Similarly, so we calculate the expected death is 138. Similarly, 3.9 children are dying per 1,000 population in the age group of 5 to 14. How many people will die in 10,000? That is 39. In similar fashion, for each age group, we have calculated the expected death, and it came for Camden, it comes around 1189.5. So 1189.5 people expected is the expected death per 1 lakh population. So what is In 1000, so the direct standardized rate for Camadine is 11.9. Now you see 11.9 and in London is 9.4. So when you compare the crude death rate, London was not performing better. But when you have standardized it, London is better performing than Camadine. So this testifies that crude death rate is not a right indicator to compare because age acts as a confounder. So we need to do standardization. In this example, we have done direct standardization. So what are the take home message from this? Take home points is we need to apply the age specific death rate on the standard population to calculate the expected death. So we need to take a standard population for both the cities. As see 1 lakh population in the we have just divided into age groups. We have taken here also, we have taken here also. So this is the way you do direct standardization. I hope it is clear. Now let's take the second one. This will finish it. Indirect standardization. Okay. We are doing standardization but it's indirect. In this what you do? You calculate the standardized mortality ratio. So SMR. So we'll calculate the expected death assuming that study group experienced the death rate of standard population. Age specific death rate of standard population is applied on study population. And what is standardized mortality ratio is observed death by expected death. But by reading these 4 sentences, it doesn't make, it is not very much clear. Once again, we need to take example. Then only we are going to understand. Let's take this, students. So national death rate in each age group is already given. See, 25-34, 3 people are dying. 35-44, 5 people are dying. 45-54, 8 people are dying. 55-64, 25 people are dying. So this is the national rate. So we want to check, can we apply the same national rate on a study population which you are going to do? So in this example, the study population is doctor population. So we have taken the study population as doctor population. It is given here. 300, 400, 200, 100 out is 1000. Okay. Observed death already we know. This is the observed 9. So let's try to do standardization, which is indirect here. If I say again the same way as I discussed in direct standardization, what is this 3? 3 means 3 people are dying in the age group of 25 to 34 per 1000 population. How many people will die in 300? So if you in 1003, so in 300, 0.9, this is the expected death. 5 people are dying in the age group of 35 to 44 per 1000 population. How many people will die in 400? That is 2. 8 people are dying per 1000 population in the age group of 45 to 54. How many people will die in 200? That is 1.6. Similarly, for 25 people are dying per 1000 population in the age group of 55 to 64. How many people will die in 100 population? So that is 2.5. So this is your expected death, students. Expected death in this population, doctor population. Okay. So standardized, you have the observed death, you have the expected death. Now what is standardized mortality ratio? Standardized mortality ratio is observed death divided by expected death. What is the observed death? Observed death is 9. Expected death is 7. So your value is 1.29. So if the standardized mortality ratio, if it is more than 1, risk of death is more in study population than the standard population. So in this example, students, risk of death in the study population, which is doctor here, is more than the standard population. So this is the way you do indirect standardization. So what I have done, we have taken the national age specific death rate of different age composition, and then we have applied in the study population, and then we are trying to calculate the expected death, and then we have calculated standardized mortality ratio. If it is more than 1, risk of death is more in study population than standard population. So this is the way we need to understand standardization. It is easy, but if you understand how you are calculating it and how it is done, then it becomes quite easy, and it sticks to you for long term. Okay, so just a comparison of direct and indirect standardization. In direct standardization, what we have done, just remember, we have applied the age specific death rate on the standard age structure, which was standard population which you took. In indirect, what you do, use the standard age specific death rate on the actual age structure. Actual age structure was doctor population in the example which I took. In direct standardization, we took the age specific death rate on the standard age population, which was the Euro population. Okay, number of deaths in each age groups is available. Normally in indirect standardization you don't have that. Population in each age group is available in direct standardization. In indirect standardization we don't have that. Okay, so this is a snapshot of measurement of mortality. So it was great, you know. So tomorrow's the measurement of morbidity is left, and I'll be seeing, or if you have any questions I'll be taking in the next class. And means tomorrow also I have a YouTube class, please join. And tomorrow I'll be also taking questions on, questions asked in NEET PG 2020, and then we'll be also discussing all those questions. And the morbidity part where incidence and prevalence is left, I'll be taking that also. And then we have second sessions. We have two sessions. I have planned two sessions for you students on all the questions asked in NEET PG, and they with explanation. So it was great, you know, it was great. So a very good morning, a very happy new year once again. Okay, let's see you tomorrow. Okay, thank you very much for joining.